Hello engineers. Welcome to this video. Today we learn how to calculate voltage regulation in a 33 kV loaded line at the tail end. In this session, we will explore the voltage drop occurring along the line and compare the voltage at the tail end to that at the sending end. Before start the calculation, we understand about the voltage regulation. As you aware that and seen commonly that, when a water tanker carries water and from one location to another there must be loss of water. Means the water filled in sending end is not available at receiving end. Similarly, the electricity behave like a water tanker due to its material properties and characteristics. Here also, we observe the drop in voltage in tail end as compared to the sending end. This drop in voltage creates a huge problem to operate the equipment. Now, let's look at the voltage regulation formula. Remember this for future reference. Voltage regulation is equal to 1.06 multiplied by active power, multiplied by line length, multiplied by power factor, divided by the product of the load diversity factor, regulation constant, and diversity factor. Here, we will explain each abbreviation one by one. Feel free to take a screenshot for better understanding and reference. Please note that the regulation constant depends on the current carrying capacity of the conductor and the length of the line. It is always measured per 100 KVA-km. In the next step, a table is provided. This table contains the values of conductor constants in KVA-km for different types of conductors at various voltage levels and a constant power factor at 0.8. For future reference, this table should be referred to when calculating voltage regulation. It is important to note that the regulation constant depends on the current carrying capacity of the conductor and the length of the line. It is always measured per 100 KVA-km. Here we have a single line diagram having a load at different point of length. Pause this video and note all the load at different points. Now we calculate the voltage regulation at tail end on line, that is, at point F.
Hey engineers! Before calculating voltage regulation at the tail end, make sure to simplify the actual single-line diagram into a more manageable single-line diagram. This simplified diagram represents shorter tapping lines as point loads on the SLD. Remember, the tail end should be identified as the point farthest from the source.
Now, in step 1, we calculate the KVA-km from the single-line diagram. First, for FD is equal to 5 multiplied by 16 is equal to 80, and then BD 13 multiplied by 20 is equal to 260, and at last up 23 multiplied by 30 is equal to 690, and the total KVA-km is equal to 1030. Now, substituting these values into the voltage regulation formula as we discussed earlier. Then the final value we got voltage regulation is equal to 25.13%. This voltage regulation is too high for a system, and this indicate the management must take a corrective measure. In the other video, I will explain the corrective measures if this condition observed in a line or a system. Also, I will explain the calculation of voltage regulation in a 11 kV line at tail end. Instead of seeing rubbish reels, find the voltage regulation at point G in the SLA shown and give answer in comment. Thank you for watching. Please do practice at least 3 times to be an expert.